Hi everyone, today we're going to use another method to solve quadratic equations, and this method is called completing the square method. First, let's refresh our memory on from a previous lesson, how to solve equations by taking the square roots. We're going to use this tactic as part of the completing the square actual method. So if I have x squared minus 72, first thing I'm going to do, I'm going to add 72 to both sides. And I'm going to get x squared is equal to 72. And then I'm going to solve for x, so I need to perform the inverse operation of squaring, which is the square root. And I'm going to get two answers, positive and negative square root of 72, which can be simplified to positive and negative. I can rewrite 72 as 36 times 2, which gives me the answer of positive and negative 6 root 2. Example E. Please, if you remember how to do it, pause the video, finish them on your own, and then you can play it to check if you were correct. I will continue. So add 5. So I get 3x squared is equal to 13 plus 5 is actually subtracting, not adding. Making mistakes, and math is just something natural that everybody do. So 13 minus 5 is 8, divide by 3, x squared equals 8 over 3, and I'm going to leave it like that. I don't need the decimal. Fractions are perfectly okay. Taking the square root will give me the answer of positive and negative square root of 8 over 3. This is the answer. Nothing we can do to simplify it more. Right, last example. Same steps. Add 24 to both sides. I get 2 times quantity x plus 3 squared is equal to positive 24. Then I'm going to divide both sides by 2. And I will get x plus 3 squared is equal to 12. And I'm going to proceed like a regular. If I had just x squared, I just have x plus 3 squared. I'm just going to take the square root of both sides, and I will give me x plus 3 is equal to square root of 12. First of all, I have positive and negative. Square root of 12 is 4 times 3, which will give me 2 root 3. And now to get x all by itself, I need to move the 3 away from it by subtracting from both sides. And I will get x is equal to, and I'm going to write this first. So it's going to be negative 3 plus or minus 2 square root of 3. It looks complicated, but this is the answer. If we use a calculator to actually simplify it, we will get a decimal form of this answer. Alright, now let's move on to today's lesson. And today's lesson is going to, we're going to use completing the square method. And we have a few steps to follow, and they're written on your notes. If you forget, you can always refer back to them. But unlike setting the equation equal to 0 in the factoring method, we are going to actually rewrite it when the constant term will be moved to the other side of the equation. That's step number 1. Number 2, if we have a leading coefficient other than 1, we need to divide the whole equation to make the leading coefficient 1. Then we're going to complete the square, and I'll show you what the completing the square is. I'm not going to read this stuff to you. And I'm going to use factoring, which we reviewed a few lessons back. And then we're going to use the square root method to finish up the problem and simplify as much as we can to get the answer. So let's actually let's use those steps. You can always look them and follow along. So let's look at the first equation. X squared minus 18x plus 56 is equal to 0. So step number 1 is to move the constant term, the c term, away from the left term, the left side. So I am going to subtract 56 from both sides. So I'm going to have x squared minus 18x. You need quite a room, so try to squeeze in. Is equal to negative 56. Now I'm going to complete the square, which means I'm going to create a perfect square trinomial on the left side that I can factor later. And the way we're going to lay it out is the following. We're going to rewrite it. So I have x squared minus 18x. I'm going to leave a room for my square to be completed. Is equal to negative 56. And because I'm adding a value to the left side of the equation, I need to add the same amount to the other side to keep my equation balanced without changing the meaning of this equation. And completing the square method is the following. We're going to use the b term, the Miller term, which is negative 18. And I'm going to divide, this is the actual formula. I'm going to divide it by 2. And I'm going to square it. And my answer will be added to both sides. So if I take negative 18 and then I will divide by 2, I get negative 9. When I square negative 9, I get positive 81. Now, I'm going to I have x squared minus 18x plus 81 is equal to negative 56 plus 81 will give me, if I'm not mistaken, is going to give me 25. Now look, this side can be factored. Factors of 81 that are up to negative 8 are negative 9, and negative 9 is equal to 25. X minus 9 twice is just x minus 9 to the power of 2 is equal to 25. And now I'm going to take the square root of both sides to cancel out the square. And I get x minus 9 is equal to positive and negative 5, which means I'll get two answers. I will find them, but first I need to add 9 to both sides, which means I need some room, 9 plus or minus 5. And what does it mean? It means that I have 9 plus 5, which is 14, or I have 9 minus 5, which is 4. Let's look at example number 2. 2x squared minus 16x is equal to negative 34. I see that the last term is already on the other side, so I'm ready to go. But I notice I have a common factor of 2 that I can divide everything by. So if I divide everything by 2, because my leading coefficient must be 1, I get x squared minus 8x is equal to negative 17. And I'm going to proceed again by completing the square. So first, I leave my spaces. Then I'm going to take negative 8 and I'm going to divide it by 2 and I'm going to square it, which gives me negative 4 squared, which is positive 16. And I have x squared minus 8x plus 16 is equal to negative 1. I'm going to factor the left side. factors of 16 that are up to -8 are -4 and -4 is equal to -1. Take the square roots. So I get x minus 4 is equal to positive and negative square root of -1. And we know that square root of -1 is an imaginary number I. Then I'm going to add 4 to both sides. And now I have a little of a problem because now I have imaginary number plus a real number, but that will give me a complex number. 4 plus or minus I. And this is my answer because I can't add real numbers with imaginary numbers. Alright, the next two examples are a little advanced. They require working with fractions. So bear along and try to stay with me on these. You can always pause, you can replay and follow along. Alright, the next example, 4x squared minus 8x is equal to -3. First, the leading coefficient is 4, so I'm going to divide everything by 4. So I get x squared minus 2x is equal to -3/4. At this time, most people panic. What do? We have a fraction. We're just going to deal with it along as we go. Let's complete the square. I'll try to make my font a little smaller so I can fit all my work in it. All right. We're using the spaces, and then we're going to use, I'm going to write it on the side. -2 divided by 2 squared is 1, so I'm going to add 1 to both sides. The left side, at this point, I hope you notice that the left side is going to factor to x minus 1 squared is equal to, and -3/4 plus 1 is just 1/4. So that wasn't too bad. Now we're going to take the square root of both sides. So x minus 1 is going to be positive and negative square root of 1/4. And now we take the square root of numerator and denominator separately. So we get square root of 1 is 1, square root of 4 is 2. And we're going to add 1 to both sides. So my answer becomes 1 plus or minus a half. So I'm going to add 1 plus 1/2, or we're going to do 1 minus a half. In the first case, we get 1 and 1/2 is 1.5, or 3/2. And in the second case, 1 minus a half is a half. Alright, the last example. We need to get 8 out of the left side. So we get 3x squared plus 10x is equal to -8. We need to divide everything by 3. We could have done that before we subtracted 8. It doesn't matter. So we get x squared plus 10/3. I would encourage everyone not to turn anything into decimals until your final answer. Work with fractions, it's going to be much easier completing the square. Is equal to -8/3. Believe me, and you can use your calculator to actually calculate adding and subtracting fractions. So here, let's complete the square. We have 10/3x, and you know we're going to be adding something. So on the side, and that's going to probably, I'm going to work it out by hand, but you're free to use a calculator and take 10 over 3 and divide it by 2 and square it. And I'm sure you will get the answer, turn it back into a fraction using math and fraction. But good SAT review. How to divide fractions. You keep the first fraction, you turn division into multiplication, and you take the reciprocal of the second fraction. So, right here. So, dividing by 2 means you multiply by a half. So now I have 10 over 6 squared. 10 over 6 simplifies to 5 over 3. And when I square it, I get 25 over 9. And I'm going to, this is my term that completes the square. And when I factor the left side, I get x plus 5 over 3 squared is equal to, and then I need to add fractions, so let's review that as well. My common denominator for 3 and 9 is 9, so negative 8 over 3. We have to multiply both by 3. So negative 8 times 3 is negative 24 plus 25 over 9. And we get x plus 5 over 3 squared is equal to 1 over 9. Take square roots. We get x plus 5 over 3 is equal to positive and negative 1/3. Subtract 5 over 3 from both sides. So we will get negative 5 over 3 plus or minus 1 over 3. And now we're going to get two answers. The first answer is going to be negative 5 over 3 plus 1 over 3. And I will continue. So we're going to add numerators. So negative 5 plus 1 is negative 4 over 3 is one of the answers. And the second answer is going to be negative 5 over 3 minus 1 over 3, which becomes negative 6 over 3, which is just simply negative 2. That completes going over examples. So now take a moment and below describe how to solve quadratic equations in your own words using completing the square method.